Hello. Welcome everybody. My name is Paul Burt. I'm a developer evangelist for Iron.io, and today I'm going to talk to you about a few components of modern infrastructure. So, our topic today are going to be message queues and workers. Those are two products that we provide through Iron.io solutions. Let's dive in and take a look at what both of those guys look like. This is going to be a very high level overview of how each component works and where it fits into the picture of modern infrastructure. So message queues. As I mentioned, IronMQ is a solution we offer, but there are many message queues. There are also a lot of names for message queues. You may hear them called MQs, push queues, pull queues. This depends on how you retrieve a message from the queue. Pub sub or publish and subscribe model is another way of talking about message queues. All these roughly mean the same thing, and essentially what it is a way to pass information around in a language agnostic way that is fast, high throughput, and gives you some security. So let's talk about where these appear in the day-to-day usage today. So the first is in SOA, or service-oriented architecture. Message queues, because they're language agnostic, are great for loose coupling. If you have a lot of languages you're working with, say you're working with microservices as well, message queues are also great for that because they tend to be very language agnostic. A lot of message queues are based on either a REST API or I think there's other protocols like AQMP. But basically, they're pretty standardized. So IPC is another great use case for message queues. That's just inter-process communication. So even if you're not inside of a service-oriented architecture where you would need pretty strong inter-process communication, you might find message queues elsewhere. So in Microsoft Windows and Linux, you'll see message queues like MSMQ, or in Linux, there's a very rudimentary POSIX message queue that comes with the kernel. And you'll see them also in just basic apps on your mobile phone for storing, sorting, working through information. So, one such app is Untapped, which is a nice social beer drinking app for, sharing the drinks that you like with your friends. So basically, message queues are everywhere. They're a great way to securely, safely, and in a very highly scalable way, pass information around between different pieces of code. So they're very popular, and most people who are not familiar with message queues usually end up reinventing the wheel instead of just using an off-the-shelf solution to kind of scratch that itch. So I like to think of message queues in an analogy as kind of like a coat check. So those were kind of concrete examples. This is going to be a little more metaphorical. So in this coat check example, you may walk into a restaurant with a coat and a hat. You may have a bunch of other stuff with you as well. And basically when you put that stuff behind the counter, you're expecting that it's going to be secure. You're going to have a ticket that's going to grant you access to that stuff that you've stashed, and you can either take one piece or as many pieces as you want while you're in that restaurant. This is not something that would work for, say, long-term storage necessarily, but if you wanted long-term secure storage, you would probably go to a bank, and going to a bank is very inconvenient if you need to be working with things. Or say, like, your coat or your hat, if it's cold out, you're going to want to put that on or take it off pretty regularly. So message queues are for information that is going to be consumed or processed in the near term generally. So the key insights around why you'd want to use a message queue, just to reiterate some of those. It's secure storage, it's language agnostic, and it's fast. It's high throughput. It can keep up with a lot of the demands that you're passing around. So that's kind of what you're looking for inside this kind of a tool. Big question with message queues is why not just use a database? Well, the first answer is locks. If you are reading and writing to a database a lot at the same time, then the database is probably going to have problems locking up the information. So most, I guess, naive attempts to implement a message queue-like system without actually using a message queue kind of go to databases. That's a great default, but they just don't scale because of locks. Next up is most databases are very hard to scale. They tend to be monolithic and hard to distribute. So if you look at MySQL or Postgres or any of those other kind of standard relational database models, there's a lot to them. They're very complicated, whereas message queues tend to be very simple and have some simple routing rules, simple channels for where things should be delivered to, how things should be stored, all that jazz. So message queues have kind of the right level of complexity for dealing with the issue of loose coupling or, as we mentioned, inter-process communication. So in conclusion, just kind of wrapping this whole thing up, message queues are scalable, they should be safe, and they are great for simple communication between different bits of code. Next up is workers. So workers are in the Iron.io world. We provide a worker solution called Iron Worker, which you can build with Docker images or a few other ways. Workers may also be called ephemeral computing, a job processor, a task runner, serverless computing. These all essentially mean the same thing. It's a bit of code that takes over some small amount of computing resources, and then when its job is done, it either moves on to the next task that it's been given, or if there are no tasks, it releases that computing resource back into the pool so it can be used by whatever other processes you have running on your business servers. So what are workers used for? Workers can be used for anything from generating email templates and sending tens of thousands of emails at a time. We see people using workers for genetic analysis. That's both, doing ETL on genetic type information and then doing data analysis on that information after it's been stored and normalized. And we also see workers used for image and video transcoding. So it's a highly scalable way to, marshal your computing resources towards a pretty intense task. So I like to think of workers as supercharged actions. They're doing something, and then when they're done with the doing, they kind of go to sleep. And the really nice part of the worker kind of paradigm is they scale effortlessly. So it's kind of a very simple mental model for how to scale them. A worker, if you need more stuff done, you just add more workers to the pool that are doing the thing, and it all just kind of flows naturally from there. There's no mental gymnastics required to get this thing working. So an actual use case for workers is Hotel Tonight. They use it to do ETL processing. They service multiple cities around the world, and they have to get same-day information for hotel availabilities and update that information in a pretty tight kind of time constraint. So this is what some companies might call a data pipeline. And you'll also find workers used for things like batch processing and burst processing. It all kind of depends on how you set up the worker architecture to work for you or your particular use case. In the more metaphorical world for workers, I like to think of workers as kind of like a deli. So When you walk into a deli, you kind of write down your order on a little piece of paper. It's just information about what you want done by the person behind the counter, and then hopefully some handsome guy, handsome gal behind the counter cuts up a piece of meat and serves you a sandwich to your specification. There's always the question of what if there's a line in the deli? So, the simple solution is just add more workers. So this is the simple mental model we were talking about earlier. In this deli scenario, if we have 100 people each standing in line with a specific order written on a sheet of paper, the more workers we add to make those sandwiches, the easier it becomes. And then as soon as the line kind of diminishes, the guy running the front of the deli shop can kind of wave these other dudes off, and they'll go back to the back doing whatever they were doing before, cleaning equipment, unloading supplies, that sort of stuff. And hopefully, at the end of the whole process, everybody's happy and has a nice, beautiful sandwich. So this just assumes, your workers are doing the right thing, and everything moves efficiently. So it's a very natural way of thinking about getting something done, which is why I like the model as compared to a lot of other distributed computing. So key insights for workers, they're simple to scale. They are a natural development workflow. You don't have to write fancy code or think about threading or any other really crazy kind of logic. And workers are right-sized for the job. So, if I only need a certain amount of RAM or a certain amount of CPU to get something done, I can restrict my worker to that size. And then that means on whatever computer the worker code is spinning up on, we'll have that many more workers available to kind of crunch through whatever data we're processing at the time. So there's a good question with workers. Why not just use some other distributed computing abstraction? I personally, as I mentioned before, I think they're somewhat difficult to debug. They're not natural mental models. So when you run into an error or you have an issue, it usually takes you days to kind of figure out what's happening because you're writing code to this very specific kind of paradigm. And speaking of specific paradigms, this is the other kind of disadvantage with these kind of crazy models for distributing your work. They kind of put golden handcuffs on you once you start using them. Once you start using a service that takes you out of your normal flow, you're really committed to it, and stepping away from it becomes exponentially harder the more you have invested. So, in summary, workers are intuitive. They're really easy to scale. You just add more workers to whatever job you're doing and it goes faster. And, ideally, workers give you choice and control over where you're running your software and how it's being run. You have a lot of options for customizing this stuff. And that's it for our introduction today. So if you have more questions or want more information on either message queues or workers and how they might benefit you or how you might use them in day-to-day life, feel free to visit iron.io.